looking at a roadway section that had control established using a total station and a level loop. A scanner was brought back in and the positions tied into the control. The data has been brought into Scene and registered into the control. Now we're ready to begin feature extraction. There are essentially two methods for feature extraction, automated and manual. There are a couple of software programs available that do automated extraction, and they come with their own pros and cons. What I'm going to look at today is the Surveyor App for Scene software that will allow me to manually extract these features, which also gives me the full control of this extraction. In the Surveyor menu, I'm going to extract cross-section data. I'm prompted to establish basically the line that I want to take the cross-sections from. And I'm simply going to pick 2 points here in the middle of the project and hit enter. Once I've established that line, we're then prompted to establish the width of the cross-sections. So I'll pick 2 points to establish a width. How often would I like these cross-sections? I can go every 10 feet, every 20 feet, 25, 50, every 100, whatever my job requirement is. The length of the cross-section is based on the width that I picked previously. I'd like to round to nice numbers. I'm then asked to give the cross-section width. Depending on the amount of data, I can reduce the width of the cross-section, showing less information, or I can increase the width, showing more. I'm using a 1/2 foot thickness, which should be an adequate width to show this process. Once the app has had the opportunity to process the point cloud data, I'm given the cross-section window. I can make this as big as I want or as small as I want, and I can advance through the cross-sections. I can change the width of the points, and using the scroll wheel on my mouse, I can zoom in and zoom out. My process would be pretty simple at this point. I would pick a point that I want. The app snaps to the nearest point, and then I give it a code. So I'll call this break line 1, for example. And I can zoom in and make sure I'm getting as close to the bottom as I can. Now, if I'm not seeing enough information, then I either need to go back and look at what my scan resolutions were. Maybe we need to adjust this for future jobs, or I need to make my cross sections thicker to pull more data into these cross sections. Okay. The program does snap to the nearest point, so I don't have to worry about where am I picking and is it getting the right point, is it getting the correct location, is it actually snapping to something or is it not snapping to something. It is actually snapping to the point. I'll move to the other side. I'll pick the flow line here and then the face of the curve. So a couple of things that I look at when doing this is no matter what program I'm attempting to do this from, the number one question is, well, what about the accuracy of this? How do you know you're getting the right point? How do you know exactly where that flow line is? And I make the same determination that my field crew makes. My field crew is taking a best guess on what that point should be, what that location should be. The difference between what they're doing and what I'm doing is that, number one, they have the diameter of the survey pole plus the factors of whether or not it was level, whether or not it's been calibrated, whether or not they hit the exact center of the mirror. They have variables included in their position that I don't have. I'm looking at dozens of points to determine what that correct low point should be, and I have a better viewpoint of this looking at it from a cross-section as opposed to standing out there on the side of the road looking at this. In my professional opinion, I think we're going to be at least as accurate as a crew collecting this with conventional methods, but realistically I believe we're getting more accurate representation of these features. And again, we can always cut the cross sections thicker or change our settings in the field to collect more data, therefore reducing that error or minimizing that error even further. I'll advance to the next cross section and I'll repeat the same thing. I'm going to pick my cross sections here, break line 1. I'm going to come in at the bottom and pick break line 2. If we hit a situation where debris were blocking that lower break line, we'll see that a lot in the flow line, for example. We could change how we do this. For example, we could skip this cross section, advance to the next one, and let it create the point at the next one. Remember, we're doing these every 20 feet. My field crew probably would have done this every 50 or 100 feet. So even if I miss one point in here, if I decide that I can't adequately determine this flow line location because of debris, then I can skip to the next one and I'm still collecting more information than we would have using the traditional methods. So natural ground, and then we'll advance to the next one. So my process would be, as simple as this. I use whatever coding system I would normally use with my office software. So if I'm using Civil 3D, if I'm using Carlson Survey, that's the process that I would use. As long as I keep my coding consistent, I should have no problem importing these into my survey software. And a break line 1. Okay, so we could continue through these cross sections, picking everything if I wanted to add natural ground shots in. Same thing on the road if I wanted to add natural ground shots. I could add these shots in, and when I hit OK, a couple of things happen. Number one, in the drawing I can see these points. I can also see the point list that has been created. If I wanted to export this, I could tell it the format. So I'm going to say a point number, northing, easting, elevation, description, and then I would say export. That will prompt me for the location, and it will export as a CSV file. Now that's one way to create point data. Sometimes that cross-section isn't the most ideal. Let's take, for example, the stripes. These stripes were not visible to me in the cross-section. Maybe if these scans were done in color, I could have seen the differentiation between the colors. But because I have this data in grayscale, I don't have that option. So what I'll do is I'll turn off my cross-section feature, and then I'll go straight to a standard field to finish feature. So I tell it which point I want to start with. I'll start with point 200, for example, and then I'll pick my code from the list. If it's not in the list, I'll add one to it. So we'll add one called stripe. Okay, and then I'll set that as current. I can have it show the Z value if I am interested. I'm going to have it just show the description. So when I hit OK, my code or my point list pops up. And now I can come in and I can begin picking the points that represent my stripe. So there's 2, for example. I could go the same thing here. I could take the time and zoom in and get as close as I want. I'm just roughly picking these. And again, it's snapping to the point, so I'm not concerned about am I getting a point. My only concern here would be am I getting the centermost point here, and again, zooming in would take care of that for me. So this is a way I could manually place points inside my my drawing. We hear this referred to as a virtual surveyor type methodology. So those are two ways I can place points in with the codes. Another way I can go about getting this, and another common thing I need, is a series of gridded points, for example. And for the gridded points, the method I'm going to use is I'm actually going to have the debris filter come through first. Basically, we hear the term bare earth used. We're wanting to get rid of the vehicle noise. We're wanting to get rid of people, anything that's not ground. It could even be actual debris. We talked about in the curb line having leaves and things piled up in the flow line. We can actually begin to filter that out, or at least ignore those areas. So what I'm going to do is I'm going to tell it to, let's look at a half-foot grid. Anything that's less than, actually I'm going to go up to a tenth. So anything at a tenth of a foot. Okay, and then I'll apply this. And what I'm going to do is I'm going to pick a series of points here in the intersection. And then I'll hit enter. So the program will go through, it'll find those lowest points, find the points that are higher based on my filter settings, and those points will essentially be ignored when I go in and create my point grid. Okay, so we see them highlighted in red here. These are the areas that will be ignored, and I will, to this, add a point grid at let's go with a 2-foot spacing. I'm going to start at point number 500, and these are natural ground, average distance, or lowest elevation within the grid. Survey, and then I'll apply. Now the program's going to go through, and every 2 feet it's going to place the lowest elevation within that grid space. It's going to create a point at that lowest elevation. I have spot shots that I could take out as well into my surface modeling. Okay, the natural ground shots are drawing up on the screen now. This again is something I could take out instead of looking at points that are every quarter of an inch or half an inch or whatever my point spacing was. Now I have something that's a little bit more reasonable to work with in my survey program. So I could take these points out. Maybe I don't want to deal with points for that. I want to take the topography straight out. So what I'll do is I'll go in and tell it to create a tin. Now I could use the debris filter on this as well. Again, getting to that lowest ground position. And this works the same way. All I do is pick the points that I want. When I have the area defined, I hit enter, and then I let it create the tin for me. Once the tin is placed in, we could go in and look at this in close and detail, but it's no different than any other program that creates a tin. We're creating triangles between all of the hundreds of thousands of little points that were here. Once the tin is finished, I can export this as a land XML and then import the land XML into my survey software. So I'll give it a name and let it export that tin. So once I have everything ready to go here, I've done all of the work that I'm going to do, and there's far more we can do in the Surveyor app. That's just scratching the surface with the couple of basic routines and functions we can do. There are commands for trees and posts and converting things over to state plane coordinates. We have a lot of capability in this software, in this app. that we're just barely scratching the surface on. Because what I want to do now is I want to take what we've done, or at least the process that we've done, and I'm going to open this in Carlson Survey. I'm going to create a new drawing, and I will call this Survey Sample. There's not a lot of data, so we'll set the horizontal scale down to 10. And what I'll do inside of my survey software is I will import an ASCII file written from the scene software using the processes that we just showed. So I have my natural grounds and my different break lines. I'll import that. Northern easting elevation description format, 1200 points imported, and then I will use my field to finish function to go ahead and draw this. I'll tell it to draw all codes, and there's my code library inside of Carlson. And we'll zoom extent. So this is obviously a little bit more information than I showed in the sample. But these are the same. What you saw in the sample is exactly how I created these points. I added the gridded points along the road. If I wanted to import the small section of XML data that we exported, I could import land.xml file. And we called it the road sample. And we would say OK, and then that would import it. I'll overwrite the tin file that's there and let it import. And I can see the contours that it created from that data. Okay. Probably not the most ideal way to bring that over. What I would do is use the data that I have here, because I have a very large amount of information that I can use, but not an overwhelming amount like we would see in trying to create a tin from the entire point cloud. So using just what I have here, I'll go into the draw functions and tell it to create a shrink wrap, basically giving me my boundary around the data, and then we would go right in and tell it to triangulate. So I'll tell it to label contours, to draw contours. I'll have it write a tin file, and I'll just call it road. And I'll say OK. I'll pick my boundary. I have nothing to exclude. And so now we see we have some crossing break lines that we would need to go in and identify, but no other real errors. And we have created our contours, and we have created a surface. If I were to go in and say Surface 3D Viewer, my road, I could load this file up and begin looking at and working with this file inside of the Carlson suites.